Hello guys, in this tutorial I'm going to solve the question number 10, paper 1-2, May 2022. The function f and g are defined by follow f of x is equal to and g of x is equal to 2. Firstly, for AS students, I know this is a difficult function for them. But if you're studying A level, I can explain this question by many ways. But because this is difficult for AS level students, this is why the examiner sketched the graph. If you read part A, the graph shows a part of the graph of f of x state the domain of f inverse. I will give you extra information. Maybe you study A level, AS and A2 together, so you can understand well how to write this answer in this form, which I will explain. For polynomial function, for A2 students, they have a lesson how to use long division. If you divided 2x plus 1 divided by 2x minus 1, so the answer will be 2. And there is a remainder, so you can find it. This is the first method. If you use a long division for 2x plus 1 divided by 2x minus 1, as I told you, this is extra for AS students. 2x divided by 2x is 1, then I will multiply by 2x minus 1. If we subtract and change the sign, will be plus. So cancel this part, 1 plus 1 is 2. So I will rewrite this function by another form. This function is equal to 1 plus 2 divided by 2x minus 1. I think now it's easily to sketch this function by using transformation method. And it's easily now to identify the vertical asymptote line and the horizontal asymptote line. How? Do you remember how to sketch the graph of 1 over x? Then you can sketch the graph of 2 over 2x. But minus 1, this is a translation. So if you divide 2x minus 1 is equal to 0, you can find the vertical asymptote line, which is at equal to 2x minus 1 is equal to 0, so x is equal to half. This is why half is undefined. The function is not valid. So if I show this line vertically, will be at half, a vertical asymptote line will be like this. X is equal to half. X equals half. And the horizontal asymptote line, now this value. So will be 1. See, if we look at the curve, y equals 1, the horizontal asymptote line. This is for A2 students, how to rewrite this function in this form. For AS level, I will explain also another method, maybe you can understand it. It's 2x minus 1 plus 1 minus 1 divided by 2x minus 1. I subtract 1 and add 1 to the function. Subtracting 1 and add 1. It's written 2x plus 1 if you write it like this. Sorry, minus 1 plus 1, and we already have plus 1. There is no change by adding and subtracting 1 to the numerator. There is no change. Now, you can distribute the numerator over denominator. 2x minus 1 over 2x minus 1 is 1. Plus 2 divided by 2x minus 1. Now, you can rewrite this function in the form of 1 plus 2 over 2x minus 1 to get the vertical and the horizontal asymptote line. This equation, 2x minus 1 equals 0, you can find the vertical asymptote line, which is half, and this one is the horizontal asymptote line. Forget about this part. Let's start now to solve part A. He asked to state the domain of inverse. If we have a function f of x and its inverse f inverse x, domain range domain. We have here domain and range of a function, switch domain range domain. from the graph, what is the range of the function? The range of the function, the values of y of the function. The values of y more than 1 or y less than 1. More than 1 or less than 1. This is the range. So the range of the function, the range of f of x is y more than 1 or y less than 1. But when we change the domain to range, you have to interchange. Instead of writing y, write it x, because he asked to get the domain. So the final answer, domain of f inverse, x more than 1, x less than 1. You can write it by using negative infinity to 1, by using intervals, but it's not famous in our syllabus. We can write it like this, from negative infinity to 1, then from 1 to infinity. This is a kind of writing sets as intervals. Part 2, he asked to find the inverse of the function. Let's start with y given expression in terms of x, 2x plus 1, 2x plus 1 divided by 2x minus 1. First, switch between x and y. X equals 2y plus 1 over 2y minus 1. Cross multiplication. So x times 2y minus 1 is equal to y plus 1. We'll try now to get y subject. Expand 2xy minus x. 2xy minus x equals 2y. If we collect y together, 2y plus 1, move to the other side, 2xy minus 2y is equal to x plus 1. By taking y outside, 2x minus 2 is equal to x plus 1. So y is equal x plus 1 divided by 2x minus 2. This is the final answer. So better to write it. F inverse of x is equal x plus 1 divided by 2x minus 2. If the question about domain range and range domain, the domain of the function, or the real number, where is x is not equal to half. This is the domain. And the range is y more than 1, y less than 1. So if I ask about domain range domain for the inverse of this function, this is part B. Part C, find the composite GF inverse 3. First, find the F inverse of 3. It's already. Find F inverse of 3 is equal to 3 plus 1 divided by 2 times 3, 6 minus 2. So 3 plus 1 is 4 divided by 4. So the answer is 1. Now we'll get G of 1. Substitute G1 and function G, x squared plus 4. X squared means 1 squared plus 4. So G of 1 is equal to 5. So the final answer, G, F inverse of 3, the final answer is 5. G inverse is x squared, gx is equal to x squared plus 4, x squared plus 4. Where is x belong to R? This is the real number for the quadratic function. For any quadratic function, for the domain real number, if we try to sketch this curve, it's a vertex at 0 and 4, 0 and 4. This function is not one-to-one by using horizontal line test. By drawing the line test, there is more than 1 point. So this function, it has no inverse. He asked to explain why. Just write because it's not 1 one-to-one function. It's not one-to-one function by using the horizontal line test. Show that 1 plus 2 over 2x minus 1 can be expressed as 2x plus 1 over 2x minus 1. As I told you before, I explained part out of the syllabus for A to level. This is why the examiner wrote the inverse. He starts with the expression 1 plus 2 over 2x minus 1 because we can now use two fractions, write it as a single fraction to show that 2x plus 1 over 2x minus 1 can be written in this form. Now it's easy to start with this expression to show that it's the same by using fractions 1 over 1 plus 2 over 2x minus 1 by finding the common denominator, which is 2x minus 1. Then find the numerator up. It's 1 times 2x minus 1 plus 2. So the final answer is 2x minus 1 plus 2. So the answer is 2x plus 1 all divided by 2x minus 1. Hence, find the area of triangle enclosed by tangent to the curve y equals f of x at x is equal to 1, x-axis and y-axis. Let's start first to draw the tangent. By drawing a tangent at the given point, ask to get tangent at 1. Tangent at 1. By drawing the tangent at 1. We'll show you the tangent at 1. Just touch the curve at 1 like this. This is the tangent. The tangent touch the curve at 1. Ask to get the area between tangent, y-axis, and x-axis. He asked to get the area of this triangle. The area of this triangle is equal half base of 2. It's a right angle triangle, so you have to get the base and you have to get the height. So it's easily if we have the equation of tangent. Equation of tangent connected with differentiation. How to find the equation of tangent for the curve? First, we have to find the gradient, substitute by the point, find the gradient, then y minus y1 equals m times x minus x1. It's given at x equals 1, so you have to get the y coordinate. You can substitute x with 1, so this value will be 3. Divided by, substitute by 1, so the answer will be 1. 3 divided by 1 is 3. We have now the point 1 and 3. What else you have to find? You have to get differentiation. Why the examiner in this question give you this form? First, because it's hard for AS level to get it. A2 level, inshallah, we can get it by many ways. Secondly, in our syllabus also, we cannot differentiate. For A2 level, if there is some students take A level, they can use U over V. It's not included in AS. This is why the examiner gave the function now written in the form 1 plus 2 over 2x minus 1 to be easily to differentiate or integrate. So if we start with a differentiation, how to get f dash x, you have to write it and they use a chain rule. I will write it 1 plus 2x minus 1 all to the power of negative 1. Start to differentiate f dash x to get the gradient. Differentiation of 1 is 0, 2 is constant, drop the power, then minus 1 will be minus 2 multiplied by the derivative, drop the power, then minus 1, differentiation of this bracket will be 2. Simplify will be minus 5 into 2x minus 1 all to the power of negative 2. You can, sorry, it's 4. 2 times 2, it's 4. You can write it like this, negative 4 divided by 2x minus 1 all to the power of 2. The point 1, I will find the gradient of tangent, substitute x with 1, minus 4 divided by 1, 2 minus 1 is 1, 1 squared is 1, So the answer is -4. This is the gradient. It's clear that the tangent slope is negative moving down. So this is the gradient of tangent. Now we'll get the equation of tangent. Y minus y1 is equal to mx minus x1. The point is 1 and 3. The gradient of tangent is -4. So y minus 3 is equal to -4x minus 1. Simplify, x is equal -4x plus 4 plus 3. So the final answer would be y equals -4x plus 7. Now we'll find the intersection with x-axis and the intersection with y-axis. To get the intersection with the x-axis, just write y0. So 0 equals -4x plus 7. So x is equal to 7 over 4. So the coordinates of intersection at 7, 4, 0. To get the intersection with the y-axis, which represents the y-intercept, x is equal to 0, so y is equal to 7, so the point will be 0 and 7. Now look at the graph. We already have now the intersection with x-axis and the intersection with y-axis. This value at 7 and 4, and this value at 7. So the area of triangle have base into height. The base is 7 over 4, and the height is 7. So the final answer is have base, which is 7 over 4, height, which is 7. So the final answer would be 49 divided by 8 square unit. This is the area of the triangle, which in between tangent x-axis and y-axis. This is part A. Okay, thank you.